Today we are looking at part 2 of lesson 3.3, getting into some transforming of our log graphs. In the previous video, I started by showing you the parent functions for logs, and so we're just going to take a look at some transformations on these. I'll be taking you to the next page, but I want you to think, before I switch pages, what these would do to those graphs. So you guys already know all these rules, so you know, like on this one, it's going to go 3 to the right. As we look at ones like this, you can see that there's a positive 2. I also have a negative attached to the x, so think about how that's going to go as far as doing a horizontal shift as well as a reflection. I have a vertical stretch when you put the 2 out front. I have a vertical shift when that 2 is being added. So let's take a look at some of those guys. So I put all these sweet graphs here for you on this next page. Started out with the parent function for a log. So I'm using log base 2. I think our book mostly sticks with log base 10. Doesn't really matter. A log base 10 and a log base 2 are pretty much going to look identical, as long as it's just x and like no other numbers thrown in. So anyway, I'm doing this guy with log base 2. So you can see just it's just some basic table of value numbers that we're going to get right there. We have this one would be the basic 2 to the x graph, because remember what we talked about is a log graph is simply the inverse or the reflection of that graph across our y equals x right there, right? So if I took this graph of 2 to the x and reflected it across that dotted line, I get the log base 2 of x as its inverse right there on the other side. So what did we say happens when you do an inverse of a graph? Remember that your x and y values simply trade places. So when you had a point like 0, 1 on the exponential growth graph, 0, 1 becomes 1, 0 in the log graph, right? Your x and y's just traded places. So if you were to graph 2 to the x, these would be your x's, and these would have been your y values, right? They just traded places in order to create the log graph that you're seeing here. So we're gonna graph some of these, and I threw in some extra steps than the ones that they initially had for you, because I thought we could do ones a little bit tougher than the ones that they had. Theirs were so basic. I wanted to put in a couple extra steps on these. So what I'd like you guys to do for this one is to make sure that you are actually showing real values instead of just a rough sketch of what these graphs would become. So I already went ahead and graphed log base 2 of x. Those were the points that I identified in the table over here. So all that stuff is already there for us. So what would happen if we have here our vertical stretch of 2? We also have a horizontal shift going left 1. So let's apply that to these values in order to create an accurate table of values. This is what I'd like you guys to do in the homework today, and actually show an accurate table rather than a super rough sketch of a graph. So slide this over a little bit. So if I go back to these guys, I know according to this, I would multiply my y values by 2. And according to this, I'm going to subtract 1 from my x's. In this case, the order doesn't matter because this affects my y's, this affects my x's, so I can really just do them both at the same time. So as I go to write these down, I am subtracting 1 from my x's, so that would be negative 0.75. And I'm multiplying the y value by 2, so I should get negative 4. And so I'll just go down the list and do that with these guys real quick. So here are those new numbers. So again, from the x's I subtracted 1, from the y values I multiplied by 2. That would be our new set. Let's go ahead and plot those real quick. So I got my negative 0.75, negative 4. Let's see, negative 1/2, negative 2. 0, 0, 1, 2, 3, 4, 7, 6. So it's going to be a little off my grid, so I'm just going to do this. I'm going to show you this on the calculator, but I do want you guys to keep in mind in the parent function, as we talked about in the last video, the parent function has a vertical asymptote at x equals 0. If I shift everything to the left 1, I should now have my vertical asymptote at x equals -1. So now my vertical asymptote is here. So we got to be careful not to cross that line when you're making your graph. So if you did this on the calculator, looks pretty darn similar. Close enough. I know sometimes on these graphs it kind of looks like they cut off and they stop going. They don't stop. It keeps going. That red graph is getting closer and closer and closer to that vertical asymptote, but the pixels in the calculator can't go small enough to show you that. And so it looks like the graph ends, but it doesn't. It's just the pixels can't handle what's going on in that graph right now, so it's just not showing the rest of it. But anyway, that's what we got for this one. Let's go on to graph number 2. So how do we handle this when I have 2 minus x in parentheses? We already know the +1, that's nice and easy, vertical shift. But what about the 2 minus x? It might be easier to write it as -x plus 2. Because now I can see, well, there's a reflection here, There's a reflection here, and I have my left 2 horizontal shift. And so maybe writing it that way would be a little more clear to you. So we got 3 things going on. So the reflection across the y-axis, we have subtracting 2 from the x's, and we have adding 1 to the y values for that vertical shift. So if we kind of put those in order that it should happen. So here's our high 15. I did not have a stretch or shrink on this one, so I left out the S. But remember, we do need to follow the order of operations on this so that we don't do things out of order. So we do have the horizontal shift going left 2. We do have the reflection across the y-axis. And then we also have the vertical shift going up 1. So if I stick with these in order, I'm going to do my horizontal shift first. So I'm going to go left 2. So I'm just going back up to the original set of points that I put here in the upper left page. And so I'm going to take those points, and the first thing I'm going to do is apply this horizontal shift. So I'm going to subtract 2 from all my x's. So making sure I got them all. There we go. So I subtracted 2 from all of my x's, gave me those guys. So my y values have not changed yet. So I'm just really doing this step by step so that we don't get lost and do any of this stuff out of order. So now I can deal with reflecting across the y-axis. So what happens to a point when you reflect it from over here to over here? What changes? Well, obviously, if I go from left to right, my y value doesn't change. I didn't go up or down, right? I went to the left. So what was positive became negative. What was negative would become positive. In other words, the x coordinate changes signs when you do this. So this guy would become positive 1.75, -2, 1.5, -1, +1, 0, 0, 1 would not change, -2, 2, -6, 3. So my x coordinates are changing signs so that we can reflect across the y-axis. And then we have one more thing to deal with, which is our vertical shift. So now I need to be adding 1 to my y coordinates. So at this point my x's don't change, so I'm just going to rewrite those real quick. And we are adding 1 to the y value, so it becomes -1, 0, 1, 2, 3, 4. So those should be the new set of points. Let's just double check it. So I'm going to go into my graph. Let's graph log base 2 of 2 minus x plus 1. By the way, the little log base 2, I don't realize you guys are off camera sometimes because I get kind of going on whatever's down here. So the little log base 2 I got from under my math button. If you hit math, I go down to this option that says log base, and that lets me put in any base I want for my logs. So that's where I got that from. So anyway, here's our new graph. Let's see how it looks. And before I even plot those points, what I'm doing is checking my table. Just want to see if these points are right. So I'm going to go into table. I'm not going to see the first two because my table is counting by integers right now. You can change that, but that's just what it is right now. So, but I should see a 1, 1. There it is. 0, 2. There it is. Negative 2, 3. There it is. And negative 6, 4. There it is. So I know I'm on the right track because I'm just checking it on the calculator. So if I plot those, should come out looking like this. Do not forget, you had a vertical asymptote at 0 initially, but then we shifted that to the left 2, so then it became at x equals negative 2, but then after that we did the reflection, and then so the reflection put it at positive 2, right? Put it over here, and so that's why we're seeing the new vertical asymptote at x equals positive 2. So anyway, plot those points real quick. So it should look something like that, and that looks pretty good with what the calculator was showing us. Sorry, my graph is ugly. I'm not an artist. So anyway, so close enough, right? Okay, let's go to the very last one. So for this one, would really help to factor first to help you see that horizontal shift. So on this one, I have log base 2. And we can write this as 2 quantity x plus 2. And that's going to be the better way to see it. If you leave it this way, then we see our horizontal shift as this divided by this. So we can certainly do that without factoring. If you think of this in the form of ax plus b, that makes a your stretch or shrink, and it makes b over a your horizontal shift. So you can either see it as b divided by a, or you can just put it in factored form like this, and then I think it might help you see it a little more clear as well. So I'm seeing this 2 as my horizontal stretch or shrink. In this case, it's going to be horizontal shrink. And then over here, I can see I'm going left 2. And these both affect us horizontally, so we want to make sure we do this in the right order. So I have my shrink right here. Remember with the x's, it's like always the opposite. So we're actually going to divide our x's by 2. Then we're going to go left 2. In the order of operations, that's what this would tell us to do, is to take our x's and divide them by 2, and then go left 2, which means we're going to be subtracting 2 from our x's. So they both affect the x's. Let's apply those, see how this goes. So if I take my x's and divide by 2, I get my 0.5. 1, 2, and 4. I have not done anything to the y values, so they're going to stay. Now I'm going to go left 2, so subtract 2 from my x's, and I get things like negative 1.5, negative 1, 0, and 2. Again, my y values have not changed. And let's just confirm those points on our graphing calculator. Let's see. So I already typed that one in. I'm going to hit graph. So here's what the graph should look like. I'm going to go to my table and see if I can see these points. I'm not going to see the negative 1.5 because, again, my calculator is counting by integers, but I do see the negative 1, 1 right there. I got the 0, 2, and I have the 2, 3. So I know I'm in good shape. So if I plot those points, should come out looking like this. Keep in mind that vertical asymptote is typically through 0, but since we went left 2, so did the vertical asymptote. So x equals negative 2 should be the vertical asymptote. So I'm just going to plot those points that we just came up with. So -1.5, 0, -1, 1, 0, 2, and 2, 3. So you can kind of see that taking shape. Again, we have the vertical asymptote right here. So we always want to kind of brush right up next to that line. And there's our graph. So let me go on to next page. We're going to do some similar stuff here, but I'm throwing in some natural logs. This is the last page, so we've got a few of these graphs to take a look at. So for number 4, this one goes in line with what we were just doing. Ignore those for just a second. That's going to go with your natural log parent function. So these, we're just taking the log graph from our previous page, multiplying the y coordinates by 1/2, and that's going to give us our new set of points. So what I would like you guys to do for this is, as you are doing these, so here's your log of x. So I want you to start first with your table of values, right? So you want to write down some relevant numbers here, like 1, 0, 2, 0.3, 3, 0.5, on and on. So write down, you should have at least a few of those values down, all the way up to, and you don't have to do all of these, but maybe at least a few of those, enough to get a decent graph. And so once you have made that graph, then you can apply this to it, show the table for what the new set of values would be, and then graph those. So that's what you would do for number 4. I'm going to kind of move on here to keep this from getting too lengthy. The natural log of x is going to look pretty similar to the log of x. Here's the points that I already wrote down from the table for you. So all I did was go into my graph, hit y equals natural log of x. So graph's going to look pretty similar to the log graph, because remember, it's just a base of e. That's it. It's a log graph with a base of e, instead of 2 or instead of 10 or whatever. So if you go to your table, these are the points I pulled right off the table to make this guy. And so that's the parent function for that. And now if I was going to do something like this, you guys already know how to deal with this one. I'm just going to subtract 3 from my x's. So I'm going to take this set of values, subtract 3 from my x's, show what those new table values are, and then plot those, right? And then you should be coming up with, you can always verify it on the graph, right? If I do the natural log of x plus 3, you can not only compare your graph to their graph, but you can also even go into the table and check your new set of values and make sure that they're good too. So, but again, that one just went left 3, so you should have your vertical asymptote at x equals -3. But that one's real similar to what we've already been doing, so I wanted to get into this last one because here's where we're throwing in a couple challenges here. So I'm going to see if I can squeeze in my table from up above. So here's my 1, 2, 3, 4. So what do we have? 0, 0.7, 1.1, 1.4. So look at we have 3 essentially, 3 transformations on this, right? You have a reflection here, I have a reflection here, I also have this horizontal transformation. Don't forget, you can write this as -x plus 3, if that helps you see it more clear. So I got reflection across both axes, so we definitely want to make sure I'm doing everything in the right order, and I'm going to subtract 3 from my x's when I do this. So let's see, as far as our order of operations goes, which is looking like this, I have both reflections. So I'm going to reflect across the y and reflect across the x. I also said I'm going to go left 3. So I'm going to do that first, because that's what would come first in my order of operations. So here's my new table. So the first thing I'm going to do is go left 3. So I'm going to subtract 3 from my x's. My y values have not yet changed. Next in your order of operations is to reflect across the y-axis. So remember, to reflect across the y-axis is to go this direction, which means your x's are changing signs. And so for the next step, I'm going to change the sign on my x's so that it becomes +2, +1, 0, -1. These have not yet changed. And now I'm going to do this guy, which is to reflect across my x-axis. And if I reflect across my x-axis, that means my graph's going up and down, which is going to change the sign of my y values. So for my final step, now I'm going to change the sign of my y values. So -0.7, -1.1, -1.4. And let's just verify those before we graph everything. Make sure we're on the right track. So let's graph the negative natural log of 3 minus x. And I'm not even looking at the graph just yet. I'm going to look at the table to see if our values match. So let's see. So I got the 2, 0 right there. I got the 1, -0.7 right there. I got my 0, -1.1. And I got my -1, -1.4. So values are good. Good that we stuck with the order of operations that we've talked about. So now if you just plot those points on the graph and connect the dots, should come out looking just like this one. So don't forget, you still got your vertical asymptote because we went left 3, but then we reflected over to +3. That's why you're seeing your vertical asymptote at x equals +3.